We are Team 5, and we were tasked with the San Diego River Bridges project in the Mission Valley area. Our team consists of myself, Daniel Matsumoto, as the project manager, as well as the structural lead. We have Irving, who's the site civil lead, Matt, stormwater, Mario, construction, and Emmett as the environmental lead. This is a quick agenda of our presentation. We will first give an overview of the project, followed by the structural, site civil, stormwater, environmental, and construction. We will then end with a conclusion to our project. Just a quick project overview. We were tasked with designing a pedestrian overcrossing in the form of a bridge in order to reduce traffic congestion due to the high traffic volume of the Mission Valley area, as well as provide pedestrians with a safe route to cross the street. The first step in our design process was to evaluate each alternative location according to the criteria shown. Each criteria was given a weight, and ultimately we were able to give each location a score, as you can see on your screen. And ultimately we ended up choosing location A, which has the highest score according to the criteria shown. Just a quick overview of our structural design. We ended up going with precast concrete in order to reduce the construction time, as well as have the highest quality product.
My name is Irving Figueroa, and I was the site civil lead. A little bit the assessment I had to do was finding the best location for the construction by having the least amount of utility impacts, enough space for the construction based on the grading plan, and finding the best fit for the retaining walls and the abutment. So a little bit about the grading plan. We decided to do a 4% running slope. Based on the calculations, on the west side, we had a 249 horizontal length, and on the east side, a 292 foot length. We decided to go with a 15-foot clearance from the existing roadway to the bottom of the bridge. For the little bit more about the retaining walls and the abutment details, we decided to go with the type 1A retaining wall. We decided to go with the 12-foot height with a 1 foot by 6 foot footing, reinforced with number 5 and 6 rebars. For the abutment, we decided to go with a non-integral seat type abutment. Holding the abutment, we decided to go with the POW foundation with a length of 60 feet and a diameter of 2 feet.
Hello, my name is Matthew Corradetti, and I was the stormwater engineer and AutoCAD lead for the San Diego River Bridges project. The importance of a stormwater engineer is to be able to form analysis and understand the flow and quality of stormwater runoff. It's important to interpret areas like the flood zone and flood data because we are right next to the San Diego River, so we're going to need to form a construction site off of that, which will incorporate ideas in stormwater management and be able to work on things like plans, assist construction, and also make some calculations based off of drainage and flow rate. This is the flood zone areas we were looking at for all of the sites. In the next image here, you can see the flood zone in the blue and the 2%, which is a 100-year flood zone in the orange. Location A, as you can see, goes right across the flood zone, so it's important to design a construction site that will be able to resist that and improve drainage, which will reduce flooding. So for the drainage calculation, the total area was under 52,000 square feet. It was a very vegetated soil, and it had a peak runoff rate of 56 gallons. So we determined to get the best flow rate, we would have to use a minimum 12-inch diameter pipe. Here's an example of our drainage plan. You can see we used retaining walls and fills and cuts to help maintain slopes in the construction site, passing it on to the environmental lead.
Hello, I'm Emmett Wackford. I was the environmental engineer lead for this project. I performed an environmental assessment at each location and also filled out a full environmental assessment form at our selected site A. A study of the pre-existing plant and animal species in the proximity of each alternative location was also conducted in order to prevent any disturbance that future construction could have on the natural biota. Since our sites fall in an urban area of Mission Valley, there are little to no conserved vegetation communities as seen on the multiple species conservation program map right here. Though maybe not communities, there is a list of covered species, both plant and animal, found in urban areas such as the surrounding area of the San Diego River and Mission Valley. It is noted that native vegetation should be restored as a condition of future development along the corridor of San Diego River where our site selections are located. Another environmental aspect we had to consider and analyze was the location's proximity to the river. The additional codes and standards were laid out in the Mission Valley Community Plan, which references San Diego's municipal code. This was all taken into account when designing our bridge. Some of the supplemental regulations for special hazard flood areas in San Diego municipal codes are as follows. Not to increase the water surface elevation of the base flood more than 1 foot at any point, and notify affected adjacent communities and the California Department of Water Resources of any proposed alteration or relocation of a water course. And as we talked about earlier, the potential hazards of flooding was also analyzed for each location. And on the next slide, you'll see the area of pre-existing vegetation at each site.
The importance of the construction lead would to be help develop an effective site layout plan, as well as forming a cost estimate for the period of construction and to give to the bid team. The example below shows our main site layout plan. It is important to consider something in a plan like this, the area and square footage you're going to need for your construction zone, and avoiding things like the river and steep grades. These grades are important for the ability to place a crane down, which is a very heavy piece of equipment, as well as moving vehicles in and out of the site effectively and using it for any laydown materials you would need and other staging equipment. Another aspect that the construction lead would take on is forming a cost estimate. This cost estimate would be consisting of the price of materials, such as the concrete going into the bridge and the reinforcement, as well as areas like construction workers and the time frame of the construction, as well as construction equipment, just like cranes and vehicles, and how much to pay the big boss man. In conclusion, we learned teamwork is key. When you don't know, ask. Don't procrastinate. Rely on your teammates as much as you can, and that hard work does pay off. This was a great journey. Thank you for your time.